W. Moore, and this is a video on one of the Pure Data patches that I made called QWERTY MIDI Keyboard. The term QWERTY refers to a keyboard that is a computer typing keyboard, your standard computer keyboard. And basically, this is a patch where you can use that keyboard as a MIDI controller. It allows you to play MIDI notes throughout different octaves. It allows you to change velocity. It allows you to control pan and volume. It allows you to trigger sustain, and basically it could be useful for you if you don't want to lug a MIDI controller around, a full-size keyboard, or even some of the portable ones. This is one that's a software-based keyboard that you can use the keyboard on your computer whenever you need to. And perhaps if you're doing some inventive things, you could use it to trigger some other stuff. You don't need to know Pure Data too well to use this software. I'll be showing you how to download it and then how to use the software. And then for those of you that actually use Pure Data, the second part of the video is going to show you how the patch was built, so you can see all the patching involved in case you want to make your own customized version or something similar. So without any further ado, Crafty and I are going to take you through the tutorial. Okay, so I'm going to begin the tutorial by telling you where you can get this software. Basically, you go to lwmmusic.com and you go to the software page. And at the top of the page, I have a big PD logo here. If you click on it, or you can read the paragraph down here and click another link, you could go to the puredata.info website, and that's where you can download Pure Data if you don't have it. It works for Mac, Windows, and Linux, and everything will look the same as what you'll see in this tutorial. Now I'm going to scroll down here where I have a prototype of an older version of this MIDI keyboard. This is going to replace this, and basically you'll see a new video here of the new patch, and it'll be the video I'm recording right now. And over to the left under the title of the patch, you'll have a link right here where you can download a zip file that contains the patch. Now I'm going to go back here to a folder where I have the patch file, and this is in a folder called QWERTY MIDI Keyboard, and that's the folder that you will unzip from the zip file. And then all you do is double click this and it'll open the patch. I already have it open, so I'm just going to go down and click it. And this is what you'll see. Let me get the file browser out of the back. And basically, this is your keyboard framework. Basically, it looks like a piano keys here. And these are the keys that you press to execute notes. And the way you press them is by using your computer's keyboard. The notes here, the keys are labeled with the key on the keyboard that corresponds to them. You see they're lighting up as I hit them. And so you can have your left hand over the ASDF keys, and then your right hand over the, let's see, the HJKL semicolon keys. Now my first finger lines up here with the J. So you reach over with the first finger of the right hand for H, and the first finger of your left hand for the G. And you can basically have your fingers over the controls of your keys and be reaching all these notes. And then the letters above are your sharps and flats. So I'm using the first two index fingers of my left and right hands here to hit these two notes, and use the right or the left to get the one in between there on the Y key. So it's kind of laid out in the way your keyboard is. And here the space bar, which you can touch with your thumbs, is a sustain. And so it sends out a sustain signal. Now let's hear this. And the way we can do this is we got to go to the media menu and go to MIDI settings. And this is where you would tell it to send MIDI data to whatever output device you select. And right now I have none selected. I'm going to select this built-in sound card that I have. This is the MIDI synthesizer that's built in on my sound device, and just about every computer will have one built in. Now, if you have something hooked up externally, like an external keyboard or sound module, you can select that MIDI port. If you want to use software synthesizers, I'll show you how to do that after I use this one, because it's just an extra step for that. So there we go. So anyway, I'm not a keyboardist in the computer sense of the word, or even in the keyboard sense of the word. But in any case, this is how it's laid out. And basically, like if you play notes and hold them down, it'll hold them down. And it depends on the sound you play. Here, this is a piano sound, so it has a natural slow decay to it. If it was some other type of sound that sustains, then it would be sustaining a note until you release it, because basically you hold it down, that's note on, and then when you release it, that's note off, and the note goes away. You also have sustain here in case, hold on, there we go. You basically can sustain pitches like that and then release them. So that's a sustain, which is the space bar. Now I'm going to zoom in to show you some, well, I don't need to zoom in for this, but we will do that later when we look at how it's made. But right now, you see in the bottom corner here, we have the Z and X keys basically increase and decrease your octave. They're right below the A and S keys on your keyboard, so I put it right here too. But basically, here we go. And then if you hit the Z key, it goes down octaves each time you hit it. You can also click on the number box here and move it, or click on it and while it's red, type in a number. I put in 5 because that's middle C. That makes middle C occur right here under the C key on the piano keys. And basically you have a whole octave here, plus, it goes up to E above that, so it's an octave in a major third. And it's done naturally so that if you don't need to go totally outside the octave, it's basically making use of as much of the keyboard as possible. I didn't include the little quotes key on the end. It wouldn't fit in the graphic display nicely, and so I decided, well, it's not really worth it just to have an extra key there. Now down here, this is velocity, and this is where you can also increase it and decrease it by using these two keys that are below the L and semicolon keys on your keyboard. Basically, you can increase velocity by hitting the /, decrease it by hitting the period. So if I hit it a few times, we could hear a noticeable difference in a lower velocity. In most sounds, that results in a quieter sound, but it also can change the attack time and other things depending on how the sound's designed. But you can also, once again, type it in here, put it on 127 for full velocity, and so forth. But that's where you can basically use the keyboard to change your velocity as well as your octave. The pan and volume here does correspond to the pan and volume in MIDI, so let's see. As you saw that, it was panning left and right, but it's using the MIDI numbers 0 through 127. So if you want center, you go to 63, and that's what comes up by default when you open the patch. There we go. Volume I have default at 100. That's not all the way up. 127 will be maximum. It's MIDI ranges of 0 to 127, and basically you can control volume by clicking on it and scrolling the mouse up and down. Not scrolling, excuse me, but dragging up and down. And you could also type volume in. I don't have it corresponding to keyboard in that way because usually these are things that you may do separately. But since you may use this with a MIDI sequencer or a DAW of some kind, basically you can send volume and PAM messages in and even record them in and automate them, because here you're sending the MIDI data and you can send it in a stream and record it. So anyway, that's fine in using the MIDI keyboard here, but if you want to be able to use this with software-based applications that receive MIDI, then you would need to use some sort of virtual MIDI connection. I'm told Macintoshes have these built in somewhere, but as a PC user, I can't tell you where. You just gotta find it. Alright, so for those who are Windows users, however, there's an app for that. I did a web search and I found this website here by a gentleman named Tobias Eriksson. This is tobiaseriksson.de for Deutschland, and basically this is the main page of his website. I don't know him, and but he made a nice piece of software, and it looks like he made several actually. You click on software, you go to his software page. Loop MIDI, right here, this link, is a virtual MIDI connection that allows you to connect two different pieces of software. And since it's a free download, I recommend it. And basically, I already have it installed here. It's easy. You just run the setup file and it installs it on the spot, and you could even start using it right away. It makes an icon in your system tray that you can click open. And basically, you use the plus and minuses to add and subtract virtual MIDI ports. Each MIDI port will be 16 channels worth. I have one up here already that I put in when I installed the software, and it's still here even after restarts of the computer and everything. But I just thought I'd show you that menu. I'm not going to give you an overview of that software, but just want to show you it's pretty easy to then go here to the media menu in Pure Data, go to MIDI settings again, and this time we're going to change our output to loop MIDI, which is down here. So this is a port of 16 different channels. This keyboard controller only does one channel at a time, but you can switch them. You have a channel box up here where you can go to channel 2, 3, 4, whatever. I'm going to stay on channel 1 because the example I'm going to use uses channel 1. I've used this with sequencer and everything, and it works just fine. But right now, not this folder. I'm going to open a different folder because I have two of the same folder. Let's see, let's keep trying here. I do not have the folder open that I wanted to have open, so I'm going to browse for it quick. Basically, I have here another Pure Data patch, Golden Wave BB Synth. This is a synth that I made in Pure Data. Open the monophonic version. There we go. And it zapped on my magnifier, so let me zoom out. Sorry for that. And basically it should be loading up momentarily. There we go. Here's a synth that I made in Pure Data, and it receives MIDI. Now since I opened this up separately, it gave me a new PD menu for it, a new PD window. So now these are considered two separate instances of Pure Data, which means I can give them separate settings. I can go here to the media menu and go to MIDI settings, and now set the input of this device to loop MIDI. So now my synthesizer over here is receiving from my QWERTY MIDI keyboard over here. One thing I gotta let you know, you gotta click the window, make sure. Why the heck did that go down? Bring you back up. You don't have to disappear. just for me clicking this. You click this window, and that means it's selected. And so we're hearing my synth playing now. Now, if I had this window selected, the patch over here would not be receiving instructions from the keyboard. As you see, the synth over here will receive MIDI data and respond. So pure data patches do function when they're not selected, but they're not necessarily receiving keyboard input. I mean, if you had two different patches open and you're typing in one and it was typing in the other at the same time, it would be crazy, right? So obviously the keyboard needs to correspond to whatever window's selected. Otherwise, it would be ridiculous. So, and so here we go. We basically have MIDI happening. Now this is a monophonic, so the sustain wouldn't really do much for us. It would just hold out a note, and you could do that by just holding it. So, you know, that would be better in the polyphonic version, but as you see, it does work with other MIDI devices. You just need to set loop MIDI, your loop MIDI port, as the input of one device and the output of the other. The input of the device that's receiving MIDI and the output of the one that's sending it, which is QWERTY MIDI Keyboard. And there you go. So we have that functionality there. And so I'm going to close this now. I'm going to close Golden Wave BB Synth. Keep your heads up for that one. That one will be released at some point. It's still a prototype now. But in any case, let's look at how this is made. If you're not interested in knowing how things are built in PD and you just want to use it, you're fine now with the video. But for those of you that want to know more about how it was built and how it works, that's what we're going to do. Which means now we're really going to zoom in and look at it. Now this is a subpatch here. Basically, when you click on it, even if you're in edit mode, you can't click on individual things. You can grab the whole thing and move it around because it's a subpatch. But you basically right click on it, go to open, and now we're on the inside of it. Here's where we have individual subpatches. Each key is its own subpatch, and each of these number boxes here are also subpatches. So let's go here first to, I'm going to do channel. It's the simplest one. Basically MIDI channel by default. I have a load bang sending a 1 to it, so it's always going to be 1 by default. I set its limits to 1 through 16, so it would probably be 1 anyway. I just wanted to double check and make sure it gets sent out. By sending a bang through, it definitely sends it out, because this needs to be sent out when it opens. And then anytime you change it afterwards, it'll automatically send. And this is a send right here, send $0-channel. The reason why I have this is so that this $0 is a local variable. That means this is a variable for this patch only. And I'm using that as the name of the send, so that basically in this PD window, this patch, all included QWERTY MIDI Keyboard, this is a unique number that's generated by PD at the beginning. So this channel send is unique to this patch. You could technically open a second copy of QWERTY MIDI Keyboard from the file menu. Well, not from the file menu. Sorry, not the file menu, but from disk. And it'll open with its own separate PD window, and it's basically its own separate entity, just like Golden Wave BB Synth was before. And that means that they're separate entities and they have unique local variables too. So you could actually use two QWERTY MIDI keyboards at the same time. Click between each one to use one or the other. But since you could change channels here, there's really no point in doing that. But in any case, say you're using some other patching and you use the word channel for a send. This way it's independent and it won't be confused. I always like to use $0 at the beginning of all my send and receive symbols. So next we're going to look at octave here. This is another thing that gets sent upon loading. low bang bangs 5 in, putting us in the middle of the MIDI range of notes. And basically the way this works is the number box here, as soon as something comes through, it triggers floats. And floats basically means the float coming in will be sent out. And in this case, 5 is a float. Float stands for floating point number, which means whole numbers as well as decimal point numbers of a wide range of values. They're just called floats in programming and in pure data. So anyway, that 5 basically gets sent out 3 different ways. It gets sent here to a storage box, a float box that stores it because you put it in the right inlet. It stores the number 5 here. And then if a key is pressed, specifically key number 127, which is an ASCII code for key numbers on a computer keyboard, basically it's saying when key 127 is pressed, which is the Z key, see it? Oh, it's 122, excuse me, I misread it. 122 comes through. Since select 122 is here, when it receives it, it sends a bang out this outlet. And it basically bangs whatever's in the float box. And the float box is going to basically contain whatever the last number was that was here. Now that I hit Z, it bangs the number out, subtracts 1 from it, and then shoots that number right back into here. Which means it also goes right back into storage here to be used again. Basically, the loop is stopped here. Basically, the number gets subtracted, goes through, and then gets stored here, so that if the key is pressed again, now it gets subtracted again, and now it's 3. And that's basically the way it's set up. So now that it's 3 here, since I have the same construction on this side, when the X key is hit, now what it does is it sends whatever's in the float box through an adder, adding 1 to it, and so it increments up. So here I can increment up, increment down, and it works smoothly. And they all get sent out. So each time a new number comes through here, it also gets sent out, and it's sent as octave, that $0 at the beginning again. Alrighty, so that gets sent. Now we'll just keep that in mind as we look at this one. This one's made the same way. It's the velocity, and it's the same construction, except now we're dealing with velocity numbers. It has a range of 0 to 127, but basically it's the same thing. By hitting the / or period keys, it increments up and down. So basically it's the same construction, except here the select boxes are looking for different keystrokes, 46 and 47, which are the numbers of those keys. Basically, you could hit any key on your keyboard, and the key objects put out whatever number it is. Like here, I'm going to hit, let's see, how about an N? Because I don't think that's hooked up to anything. There we go, and you see its numbers 98. Now, when that gets put into select, it doesn't go anywhere. It would go out its outlet here, but I don't have it hooked up, so it does nothing. So basically, unless a 46 is hit, then it does something. It sends that bang out, and it increments the value down. And so, the velocity and octave units are set up the same way. These are set up similarly to channel here, in that they're very simple, volume and pan, except here they do receive channel messages, so they can send the controller out, in this case, MIDI volume control. Oh, excuse me, this is pan. Pan control is MIDI controller number 10. It gets sent with the number of the channel that it's going to, which gets received here. And whatever gets sent out is the number in here. And that number is the value of that controller. And it's the same thing for volume down here, except it's using the MIDI control number for volume, which is 7 right here. And whatever channel you select, it's sending it on. Now, let's look at the more interesting things. Those would be the keys here. I'm going to open up this key, and each one are their own subpatches. And so when you open them up, they all will look generally the same because I basically copied and pasted them. But we're going to go over the design and then I'll show you what's different for each one. Okay, well first of all we have key objects here and we have a key object here that's key up. Actually a different object, key up and key. And basically when a key is pressed the number comes here as with everything and it's looking for number 97 now. 97 I believe is, yes, the A key. And when it's A it bangs out here, which triggers several bangs. You could actually connect the bang up several patch cables, but just like in the other sub patches where I had trigger and floats, I have trigger and bangs here because I like to see my multiple sends of the bang kind of separated from one another so I could follow and trace the cables more easily. So anyway, this is what gets banged when the key is pressed. It bangs a float box here, sending out a number, and the number that's stored in it comes right from the beginning when you open the patch. When you open the patch, remember octave gets sent out. And then whenever you change the octave number later, it continues to send. You see it's on 7 right now. What it does is it multiplies that by 12, which gives you the MIDI note number. Since the A key is for all the C's, basically when you multiply an octave number by 12, you're going to get a C of some kind in MIDI. 84 is 2 octaves above middle C. Middle C is 60. Basically 12 semitones per octave is how MIDI is arranged, and all the numbers divisible by 12 are C's. So the way it starts off is 5, and so it's middle C 60 to begin with, but if you octave up, now it's 2 octaves above middle C. And that stores here, and so that whenever a note's played, it sends that as the note. And then also with it, it needs to send velocity. We have a float box here where velocity gets stored from this velocity receiver here. This receives velocity. Whatever the velocity currently is, it's stored in this float box so that when the keys press, both the note and the velocity come through here into make note. The make note sends them into strip note. Basically, make note basically takes note numbers and velocity numbers and uses them as a pair and sends them out as a pair as MIDI would. It can also receive duration values here, but I don't have any because basically I want it to sustain as long as the person's holding the key down. So there's no reason to send a duration value. And then I have strip note here, which basically takes out any zero velocities. So zero velocity is sent when basically a note is released. This is just to make sure none come through. Now this mechanism here normally wouldn't produce a zero. I just have it here just in case make note makes one. You know, with everything not having a duration, it may just send a zero right away, and so I have strip note here to get rid of that. So it basically sends note and velocity, as long as it's not zero, to these two spigot objects here. Now spigots are like valves in PD. They'll basically pass through things as long as the spigot is open. And by default I have spigot 1. That means they're open initially when you open the patch. But then when you send a 0 or a 1 to the right inlets, they can be closed or opened. And the 0 is here, and it gets banged when you press a note. Basically, when the note and velocity go through, 10 milliseconds later, you see there's a delay object here. 10 milliseconds later, this bang finally goes through and hits a 0 to close off both of these spigots. That's so that if I'm holding down a key, it doesn't stutter. Because normally if you didn't have this, it would stutter. Because when you hold down a computer keyboard's key, it starts just executing that key in rapid fire succession. But 10 milliseconds is a very short amount of time. It's enough to let the note and velocity go through. Once they're through, it shuts it off so that the successive rapid fire key signals don't get through. And so that way it just sends the note and velocity once, and then They're there, and so the note sustains in MIDI until it gets a velocity 0 message with the same note number. And that's what happens next. That's where key up comes in. When you raise the key, eventually, um, this gets triggered and releases a 97 for the A key. And they have a select box here to bang when the 97 is released. And then it triggers these bangs to happen. One of these is another float box where the MIDI note number is stored. And the other one is a 0, because when you raise the key, it's intended for the note number and the 0 to come through as velocity. And so they go straight out here through note out. They don't go through the spigots or anything, because I just want them to go straight out. There's no reason for them to go through. Besides, it's already closed. But one of these bangs goes right down here. Here, let me trace it. Goes right down. Oh, that goes to something else. Never mind. Here's the one I'm talking about. This one here goes right down to this one here, which opens the spigot. So basically, when the key's raised, the spigot's now open, and that means it can receive the key being pressed again. So you can play a note afterwards in succession. But you have to raise the key first to stop the first note before you play the second. And that's the way you normally would do things, like on a keyboard, if you're playing repeated notes. And so that's how that works. Now, you saw here, I showed you this last bang here goes to a 0 over here. This is where I'm sending color messages to the canvas here. If I go into edit mode, click the upper corner here, this is a canvas object. And basically it's laid in here within this red outline of the sub patch. And I'm sending to it color messages. And the first color message is $1, meaning whatever gets sent in here through the left inlet. And that is a 1 or a 0. When the key is raised, a 0 gets sent through, which makes the color white. And whenever the key is pressed, it sends a 1 through, which gives it a gray color, denoting that it's being pressed. And then it also sends a 2 along with that. Oh, I'm sorry, no, 252 along with that. That I just searched through and found it's the kind of like black here for the text to appear, whether it's gray or white. And that just makes sure your text is visible. And then that gets sent here, out ascend to this here, which is $0 dash key dash A dash receive. Each one of my canvases here for these keys have a different receive. Basically the same thing, except key A and the one for S is key S, and the rest of the symbol is the same. But basically that's how they're all unique and individual. It can be turned on and off when you press them. And basically the black keys up here, they're the same thing, except they're smaller in size and laid on top. As you see, after I open this one, oops, you see things get out of order. So I have to do this. Make sure I click on the black key there, put it in between. But normally, since someone doesn't open up the patch and go through it, excuse me, these will stay on top. But it's one of the limitations, you know. I'm just trying to make PD look nice. And so, as long as you don't open it up, those things will stay on top and look nice the whole time. There we go. And same thing with spacebar, except instead of being a key corresponding with a different MIDI note number, I guess I should show you that. Since this is C, this is C sharp. Let's open it. Oh, no, I actually didn't hit C sharp. You gotta get it right in here in the sliver, otherwise it goes to the key underneath. Here we go, here's C sharp. No, that's C again. I can tell because C sharp here in the middle, when I open it up, open, you see there's a +1. The difference between the different key modules here is, first of all, The select boxes here have different numbers for whatever key it's listening for whether the key's pressed or goes up. And then the MIDI note number here is different. Basically, when the octave gets sent through here, there's an adder at the end that adds 1 to it because it's 1 semitone up from C. So it's just like the middle C key down here, except this is 1 semitone up, and this one's 2 semitones up, and this one 3, and this one 4, and this one 5, 6, 7, 8, 9, 10, 11, 12. This one I have at 13, 14, 15, 16 because these are always an octave higher than these few down here. So that's how it works. Now let me go into spacebar here. You open this up, and this is your sustain. And basically, the select number is 32 for spacebar. And what happens is it triggers a bang. The first bang is to send a 1 through the spigot. Then there's a delay of 10 milliseconds that sends a 0 to the right inlet of the spigot to shut it off. So that's where, like if someone holds down the spacebar, that way it doesn't keep sending a sustain signal. Shuts it off until the key is released, in other words. And then there's still one other bang that gets executed here. That's this to color the canvas once again, just like with the keys. It colors the canvas when spacebar is pressed. Except this one's a 2. Funky. Anyway, over here, this is key up, and what it does is when the key is raised, it opens spigot so that, it can receive when it's pressed again. And it also, at a 10 millisecond delay, sends 0 through spigot, which is sustain off. So the 1 here initially is sustain on, and the 0 that comes through the left inlet of the spigot is sustain off. 1 and 0 is on and off for sustain messages. And basically down here it goes through the control out object. Controller number 64 is sustain. Channel 1 by default, but I have it receive channel messages here, so you can change what channel this gets sent out, just like everything else. Everything's on the same channel. So that's the rough idea. Now, do I want, hold on here. Oh yeah, the space bar. Well, let's see. Yeah, everything else turns gray except the space bar turns black. You know what, I'm gonna leave it that way. So you heard it here first. I decided to leave it that way. Okay, so I think that is a good overview of how QWERTY MIDI Keyboard was made. That should conclude this whole tutorial, but I do want to remind you, stop by my website. You can download it from here, and then also on the learning page is some of my tutorials on synthesis. You may want to stop by and check those out. Please do, after this video, if you feel it was useful for you, please do hit the like button or leave a comment. Subscribing to my channel will be great. You'd be notified of my different tutorials, all dealing with pure data synthesis and electronic music as more and more come out. And you can enjoy those as well. So that's about it for now. Take care, and I'll see you soon.